Happy day! Today we will begin the class with the topic number systems and how to convert from one number system to another. Digital systems have such a prominent role in everyday life that we refer to the present technological period as the digital age. Digital systems are used in communication, business transactions, traffic control, weather monitoring, the internet, and many other commercial, industrial, and scientific enterprises. The data in digital systems are stored in the form of bits and bytes. A bit can hold only one of two values, 0 or 1, corresponding to the electrical values of off or on respectively. 1 byte is 8 bits. More frequently, computer storage and memory are measured in GB or TB or 2 to its powers. In digital computer, there are various types of number systems used for representing information. They are binary, octal, decimal, hexadecimal. Information is represented by signals in a digital system. Signals use just two discrete values, 0 and 1, and therefore are said to be binary. In today's technology, binary systems are used to process information. The decimal number system has base 10 and has the digits 0 to 9. Many of our ancient civilizations used 10 and its powers for representing numbers. The octal system has base 8 and digits from 0 to 7. It is still widely utilized in file permissions within Unix and also in digital displays. It is represented by a 3-bit code word. The word hexadecimal is formed from two words, hex and decimal. Hex means 6 and decimal means 10. The sum of these two is 16, which signify its base. Since the computer is made to understand the language of 0 and 1 only, there is a need to convert the data into binary form before feeding it to the computer and also to convert it back to the decimal form for the user to understand easily, and hence the various conversion methods. We will see each conversion method in detail. The decimal number system can be converted to binary, octal, hexadecimal. The entire process of converting to binary, octal and hexadecimal is a repeated division by 2 for binary, 8 for octal, 16 for hexadecimal. So, in general, decimal to any base is a repeated step of division by its base value. 20 divided by 2, quotient is 10, remainder is 0. 10 divided by 2, quotient is 5, remainder is 0. 5 divided by 2 does not go, it goes 2 times but with a remainder 1. 2 ones are 2 and therefore it is 0. So, we will take the value from bottom up and the answer for binary is 101001 to the base 2. Do you understand? The next number conversion is from decimal to octal. We will take the example of a decimal 153 and convert it to octal. 153 is divisible by 8 by 19 with a remainder 1. 19 goes in 8 2 times with a remainder 3. So, the octal equivalent of decimal 153 is 231. We have to take it from bottom up, remember. The next conversion is the reverse, from any base to decimal. How is it? From decimal to any base was repeated division. So, from any base to decimal, it is repeated multiplication. We will see each one in detail now. From binary to decimal, we take the binary value 1011. That can be represented as 1 into 2 to the power of 0, 1 into 2 to the power of 1, 0 into 2 to the power of 2, 1 into 2 to the power of 3, which will give us 8 plus 0 plus 2 plus 1, which is 11. So, the decimal equivalent of binary value 1011 is 11. The next conversion is octal to decimal. The octal powers are 8 to the power of 0, 8 to the power of 1, 8 to the power of 2. 1 into 8 to the power of 0, 3 into 8 to the power of 1, 3 into 8 to the power of 2, which will give us the answer 217 to the base 10. The next conversion is from hexadecimal to decimal. We have taken the value D9. The equivalent decimal for D is 13. So, 9 into 16 to the power of 0, 13 into 16 to the power of 1, which is 208 plus 9, which is 217 to the base 10. We will now convert octal to binary. When we say that octal to binary, when I was telling you about octal numbers, I told you they are represented as a 3-bit binary code. So, 0 is represented as 000, 1, 001, so on and so forth. So, it is very simple. If I have an octal number 673, I just have to look into the table and replace its binary value and group it and write it to the base 2. So, what is the binary equivalent of 6110? I will write it here. Binary equivalent of 7 is 111, which I write it here. What is the binary equivalent of 3? 011, which I have written it here. So, the binary equivalent of octal 673 is 110.111.011. The next conversion method is from hexadecimal to binary. Hexadecimal to binary, we have to group it in the form of 4 bits. So, 0 is represented as 4 bits of 0, 7 as 0, 1, 1, 1. 15 or F is represented as 4 ones. Now, we have a hexadecimal number 306 to the base 16, which we will convert it to binary. 3 equivalent in the table is 0011. I will write it here. 0 is all 4 zeros, write it here. 6 is 0110. So, I will group it and this becomes the base for binary number. The next conversion which we will be seeing is octal to hexadecimal. We will take the number 175 octal. We know the binary equivalent for 1, which is 001. 7 is represented as 111. 5 in binary is represented as 101. But we have made it as a group of 3. But for hexadecimal, we need to group it in 4. So, starting from right to left, we will group it as 4 bits. So, 101 will become 1011. This one will become 1110. Now, because we need to add the equivalent for this, we are adding null zeros for it. Okay? So, the value for octal to hexadecimal equivalent will be 07D to the base 16. The next is the reverse, hexadecimal to octal. Hexadecimal, we write it in groups of 4 bits. So, we take the example 1A to the base 16. 1 is represented as 0001. A is equivalent to 10, which is 1010 to the base 2. Now, we have to convert it to octal. Octal is represented with groups of 3. So, I have to group it as 010, 011, 000 and write its equivalent value, which is 032 to the base 8. To sum up, what we have seen today are the different number systems: binary, decimal, octal and hexadecimal. We also saw the different base conversions from decimal to binary and vice versa, decimal to octal and vice versa, decimal to hexadecimal and vice versa, octal to binary and hexadecimal, hexadecimal to binary and octal. Hope you all understood these basic concepts of conversion and number systems. Do practice more problems. Thank you.